Let's jump right into this. We are looking at a massive, absolute game changer in how we understand ancient history today. In this explainer, we're unpacking the triune harmonic dynamics, or THD research. This was developed by researcher, inventor, and author Kevin L. Brown. Now, for over a century, the ancient Minoan script known as Linear A has been just a total mystery. Experts have tried literally everything to read it. But what if we've just been looking at it completely wrong this whole time? Like, what if we're desperately searching for a story when we really should just be looking at data? Here is our quick agenda for this explainer. First, the Linear A mystery. Second, the THD accounting hypothesis. Third, the three-layered grid. Fourth, breaking down the ledger. Fifth, how to test the theory. And finally, falsification and future proof. Basically, we're going to treat this ancient script not like a lost poem, but exactly like a modern corporate spreadsheet. Okay, Section 1, the Linear A mystery, a misclassified system. We really need to address the core problem right out of the gate. Why has Linear A stayed undeciphered for so long? Well, when you actually look at the physical layout of these genuine clay tablets, it's pretty revealing. It literally looks like hard data carved into clay, doesn't it? I mean, notice the straight lines, the strict sections, those repeating marks. This doesn't look like a flowing story or a casual letter or some royal decree. It looks like a record. It looks like a ledger. See, for decades, researchers just assumed this was a hidden spoken language. They thought it was poetry or a prose or someone simply sounding out their spoken words. But the THD hypothesis reveals a completely different reality. It's actually a highly structured economic grid. It's an administrative tracking protocol. The reason all these brilliant experts couldn't read the words is super simple. They aren't words in a sentence at all. They're data points in a ledger. And that perfectly tees up Section 2, the THD accounting hypothesis, the ancient spreadsheet. This is where Kevin L. Brown completely flips our perspective. As he puts it, Linear A is not primarily a spoken language. It is a structured administrative protocol encoded through mixed symbolic logic. So what does that actually mean for us? It means this script is a highly structured system, totally constrained by strict rules. It was built for tracking inventory, counting goods, and recording institutional transactions. It's a tool for accountants and administrators, you guys, not poets. When you try to force spoken language rules onto a spreadsheet, you get what Brown calls structural pressure. The whole system just breaks down because, well, you're using the totally wrong rulebook. Think about it like this. If you tried to read an Excel spreadsheet out loud as if it were a paragraph, it would make absolutely zero sense, right? Researchers tried to map the sounds from a later, known script called Linear B onto Linear A, but it totally failed. The signs don't behave like words. You have sky-high sign entropy, lots of single-use data points. And here's the real kicker. Specific signs cluster right next to numeric fields. That is exactly what happens when you're tallying up goods, not speaking a sentence. Moving right along to Section 3, the three-layer grid, positional, symbolic, numeric. So the real secret here is this three-layer information grid. The meaning of a symbol actually changes completely based on where it sits. First, you have the positional layer. Where a sign is placed tells you its administrative job. Second is the symbolic layer. The actual shape tells you its function, like if it represents a commodity or a specific person. And third is the numeric layer, which gives you the quantity or the transaction state. It's literally just like how a number in an Excel column means something entirely different than a number in the row total. The sign changes meaning based on its specific place in the grid. All right, Section 4, breaking down the ledger, reading the data. If this is an ancient spreadsheet, how do we actually read the cells? Well, just like a modern database, the signs are broken down into specific functional classes. Up at the top, you've got prefix or heading signs. These tell you the broad category or the institution. Right in the middle are the core signs. These are the actual items being counted, like crops, livestock, or people. Then you've got numeric or fractional signs for the amounts. And finally, at the very end, terminal signs. These act as a closure, a validation, or a grand total. It is just a brilliant, complete, end-to-end accounting loop. Understanding this layout perfectly explains the famous libation formula. Now, for years, experts kept finding these repeating symbols on religious items and naturally just assumed they were reading a magical spoken prayer. But under the THD model, it's not a spoken prayer at all. It's a standardized, highly structured receipt for ceremonial offerings. The headings are just telling us the category of the ledger. If you misread those headings as the start of a sentence, the entire translation instantly falls apart. Let's look at Section 5, How to test the theory. The field protocol. Any good scientific hypothesis absolutely has to be testable, right? It can't just be a wild guess. And Kevin L. Brown provides a strict, verifiable field protocol to do exactly that. Step 1, you classify the inscriptions by their layout, not by what language you think it might be. Step 2, map out how the signs repute by their positional class. Step 3, test the signs sitting near totals to see if they act like commodities. Step 4, isolate those headings to see if they correlate with the tablet type. And step 5, predict the structure before you ever even try to assign a sound to a symbol. Basically, let the math and the layout lead the way.
Which brings us to our final section, Section 6, Falsification and Future Proof.
For any theory to be truly scientific, you have to state exactly what would prove it wrong. This is a purely data-driven approach, so here are the exact falsification parameters. If applying simple spoken sounds cleanly resolves these tablets into standard, readable sentences, then the THD ledger model instantly fails. Or if the physical position of a sign doesn't actually predict its function, the positional model fails. It is really that simple. The theory openly invites rigorous testing. But conversely, let's look at the confirmation conditions. The hypothesis gets significantly stronger if the physical position of a sign consistently predicts its functional role. If a sign next to a number always acts like an inventory item, boom, the ledger model strengthens. And if those headings truly behave like category fields rather than the start of a sentence, then the administrative model becomes incredibly solid. So as Brown states in his final hypothesis, Linear A is not best understood as an undeciphered phonetic language, but as a structured logographic-syllabic accounting protocol. We've seen today how treating Linear A as an administrative spreadsheet completely solves the structural mysteries of the Minoan world. It takes away the absolute frustration of trying to hear a lost language and replaces it with the incredible clarity of reading a lost ledger. By accepting this as an accounting protocol, meaning it uses symbols for both words and sounds to track goods, the data finally actually makes sense. And you know, this leaves us with such a fascinating question to ponder for the future of archaeological decoding. If the absolute oldest unsolved scripts in the world are actually just ancient data ledgers, how many other historical lost languages are we misreading? Are we completely misunderstanding our past simply because we're out there looking for poetry when we really should be looking for spreadsheets? It is just an incredible thought. Thanks so much for joining me in this explainer to explore the THD hypothesis.